Welcome back, Grade 7. I'm so glad you're joining us for this explainer today. You guys have been making some truly fantastic progress in your programming journey, and today, well, we are stepping into something incredibly powerful. We're going to master Python variables. You know, if you've ever wondered how apps or video games or any software actually hold on to information while you're using them, you're in the right place. This is a massive stepping stone in coding. We're going from just writing static, boring instructions to creating dynamic, interactive programs. So get focused, get ready, and let's unlock this together.
So I want you to think about your absolute favorite video game for a second. When you're playing, how does the game remember your high score after you finally beat that ridiculously tough level? Or how does a social media app remember your exact username every time you log in? We kind of take it for granted, right? But a computer program actually has to be explicitly told how to remember things so it doesn't just instantly forget them. It needs a system to store that data so it can be retrieved and maybe even changed later on.
All right, let's get into Section 1. What is a variable?
So by definition, a variable is a container with a name where the contents might change, but the name or the identifier does not. Honestly, just think of it like a physical storage bin or a box with a label slapped on the outside. Imagine you have a plastic bin in your room and you write sports gear on the label. That label on the outside, the identifier, that never changes. But what you actually toss inside the box, that can change all the time. One day it's holding a baseball, the next day maybe a soccer ball. In Python, this container holds your data, like numbers or text, right there in your computer's memory. The stuff inside changes, but that handy label on the outside stays exactly the same so we can always find it when we need it.
Okay, moving right along to Section 2, naming your Python variables. Now that we have our container, we've got to label it, right? And readability here is absolutely crucial. Take a look at these examples. On the left, we've got some excellent readable variable names like player underscore, score, total lives, and user age. Notice how they're completely lowercase, they use underscores instead of spaces, and they clearly describe exactly what data is living inside that container. Now on the right, well, we have some really bad names that will literally cause errors in your code. First player starts with a number and uses an exclamation point. Python hates that. Total lives has a space in it, which will just flat out crash your program. And age hashtag uses a hashtag, which Python actually thinks is a comment. So the rule of thumb is super simple. Use clear names that represent your data properly and stick to lowercase letters and underscores.
Let's jump into Section 3, assigning and updating values.
So let's walk through the exact syntax step by step so you can see how this works. Step 1, you just write out the name of your variable. That's your clear, readable label. Step 2, you type an equal sign. Now, quick side note, in programming, we actually call this the assignment operator. It doesn't mean equal to like it does in your math class. It basically means take the thing on the right and assign it to the container on the left. And finally, step 3, you just type the actual value you want to store, like the number 10. Name equals value. Honestly, that is the whole shebang.
Check out this worked example to see how dynamic this actually is in practice. First, we do our initial assignment on the left, score equals 10. We created the container, labeled it score, and dropped the integer 10 inside. But look at how we update that variable on the right. We write score equals score plus 5, and here's the trick. Python reads the right side of the equals sign first, so it takes the old score of 10, adds 5 to it, and then that equal sign assigns the brand new value of 15 right back into the score container.
And this right here is the magic. The integer inside our container updated from 10 to 15, but the identifier, the word score, stayed perfectly constant. You could update that score a million times during a game, and the computer will never ever lose track of it because the name of the container never changes.
Let's see how you're tracking with this. Section 4, retrieval check.
Okay, read this Python snippet carefully. First, the code says lives equals 3. Then, the very next line of code says lives equals lives minus 1. Take a second to process that math. So, what is the final value stored inside the variable lives? Shout it out if you know it.
The answer is 2. Seriously, incredible job if you got that right. You took the initial value of 3, subtracted 1 on the right side of that assignment operator, and successfully placed the new value of 2 back into the lives container. You are officially tracking and updating data just like professional Python developers do.
Which brings us to our final part, Section 5, the big takeaway.
So, to wrap this explainer up, here are your 3 main takeaways for today. First, always remember our box analogy. Variables just act as named storage containers for your data. Second, always use clear, readable naming conventions.
lowercase, underscores, no weird symbols or spaces. And third, values can be assigned and updated at any time using the equals sign, which acts as our handy assignment operator. Those 3 rules pretty much cover everything you need to start managing data in your own programs.
So, I'll leave you with this one question to think about. What data will you store in your very first Python variable? Is it going to be a high score for a game you invent? Maybe a string of text for a chat app? The possibilities are literally endless now that you know how to make a computer remember exactly what you tell it. Thank you so much for hanging out with me for today's Explainer. Keep coding, keep practicing, and I'll catch you in the next one.